Hello, we're Project 3 Group 11. We're the Stack Overflow Recommender System project group. Uh, so, how have we built our Stack Overflow recommender system? What are the problems that we faced when we are trying to build the Stack Overflow recommender system? The primary reason we want to discuss this is it shows us what is the most significant important factor that led us to change our algorithms or do data reprocessing. So we were given 2 GB of data, which resulted in having 180 questions, 180,000 questions, and its corresponding answers. So that results to close to 360,000 questions and answer sets. But along with it, we also found 15,500 unique tags. And these tags were very sparse in related to certain questions and certain answers. So we couldn't just directly use, let's say, top 500 questions because it's not giving us the correct possible recommendations. We have to consider the 15,500 unique tags as it would present a proper tag relation for certain questions. But it is lacking in regards to certain topic clustering scenarios in certain questions and certain answers and in certain related question and answers. So what are we doing to resolve that? That was one of our main tenets of this project. How do we fix that, and how do we provide better content-based filtering? Is what we have considered as the thing that we want to achieve this project. So the system that we used is to use the merge tag along with Elasticsearch, which have been hosted on Heroku and AWS. And like I just discussed, what we need to achieve better topic clustering for questions because certain questions don't have proper topic matches, and we need to do content-based filtering on topics and content, and collaborative-based filtering based on topics with respect to what's the question's repetition count, the acceptance rate, and the word count. So what's the problem that we found and what we had to do to address it? The problem we found, right, is pretty straightforward. Let's say we have certain questions like for null pointer exception in array list, list, and hash map. The tags that are certain times entered by a user is null pointer exception, array list, null list, null pointer exception, null pointer, and hash map. So essentially, the question is not following in the current bucket for a large set of questions. So large set of questions are just going into the null or the pointer part, but they are providing relevant answers to people. So people are going to such questions. But what if you try to bring all these questions into one particular topic? And how do we do that? So that was one of the challenges that we decided to take up along with the content-based filtering as I discussed. And now I will discuss how we achieved that or how we try to tackle it. So the things that we used along with the data given to us was to take the Stack Overflow API data, that is the related tags. The related tags are calculated by Stack Overflow, like how we would calculate a Neo4j graph database based on the incoming and outgoing edges of each question with respect to its tags. So let's say a particular tag has array list, list, arrays, and it has another question where array list is with for loops, another question where array list is with loops. So array list is far more related to loops rather than, let's say, Maven. So that's how the related tags have been calculated by Stack Overflow. So we essentially use this in our computation because it really benefits us to determine what the current question could be related to as well. And also we pre-processed all our data with NLTK just for the title, text, and code, and also constructed different columns where you will have title plus text plus code, and NLTK title plus text plus code, as this gives us a better document to do proper searches in Elasticsearch. So how did we use all of this that I just talked about? Okay, content-based filtering. What do we want? We want to get a proper set of TF-IDF scores for a particular document in relation to other question answer documents. So let's say a document has a null pointer exception and array list on the user tags. What do? We find the related tags for it. We find the split tags for it based on the separators. We determine all the cases that could have, and we try to find if this particular tags exist in the title, text, or code. The reason we want to do this is in certain kind of questions like null pointer exception, abstract classes, OOP concepts, these questions are related more into those keywords appearing in the questions, so they would have a better topic match to these questions. And the related tags for a null pointer exception could be having tags like null and pointer, and a null and a pointer question would not be classified as null pointer exception but would also have null and pointer, so we can automatically classify that as null pointer exception too. So essentially we are classifying certain good questions into these buckets as well, which could improve our topic clustering and improve the content based suggestion we would give based on those topics. So if you look at it, the all tags found would be say null pointer 1 time, null 3 times, arrays 2 times, ArrayList one time. But if you look at the parent tags, the parent topic score that you get is very relevant to null pointer exception ArrayList. So we can essentially use this along with the other question set to say that, hey, this question is really fitting this topic, and another question also really is fitting this topic. So essentially we've kind of moved all the questions to a closer to a closer central point, like how we would do k-means clustering for a particular topic. That's what we've essentially done. So we've improved these topic scores and provided a larger set of tags. So this even improves the TF-IDF score for the document, which is what is a tenant of the Elasticsearch that we're using. So we are essentially using the power of Elasticsearch by creating more tags to improve the score of a document. So I will just show you a project demo along with our video. So this is our profile page where a user can come in and add tags or look at suggested tags or look at the top 100 tags in the community. Also, if you look at it here, we're showing something called the tag clusters, where we show what are the tag clusters created based on the liked and removed tags. So why do we have tag clusters? The tag clusters was a algorithm or a concept that we generated. Primary reason being, how do we solve the cold start problem? Or what is the cold start problem? A cold start problem is when a user comes to a system and he decides he wants to sign up, and he adds, let's say, some random tags like swing, null pointer exception, for loop, hash map, eclipse, and ArrayList. So if you notice here, swing and for loop and hash map don't have a correlation. It doesn't make sense there. So if in essence I try to search for all these tags in the system, I would get really outlier question and answers, which I do not want. But wouldn't it be better if I would get the related tags and search based on those related tag clusters? So I would essentially get questions for ArrayList, eclipse, and swing, and ArrayList, null pointer exception, and for loop. So the user would get questions related to that tag cluster and this tag cluster. So how do we achieve this? We find all the tag cluster based on the related tag count. So the related tag count is present and has a likely threshold in regards to the like tags. We add it into our tag cluster, and we use these tag clusters along with Elasticsearch disjoint max query to find the probable suggestions. So if you look at it, we use the explicitly collected tags to provide suggestions to the users. So here, if you look at it, you get a lot of suggestions based on null pointer exception, hash map, Java, and arrays. And the reason primarily being, he has there's a stronger correlation for null pointer exception and arrays and hash map and ArrayList rather than the other things, and that's what you see occurring in all the suggestions. That's what is important. A future work could also be to take the lesser tag clusters and kind of equi-join all the results. But for now, we've tried to see the tag cluster logic works, and it is working pretty well. We are giving the results which have a better relevance rather than just trying to give a set of results for all the tags, which will give really outlier results more than what is the actual result that you would want. So that's the cold start problem. That's the cold start problem that I just discussed about. Also, what is the open user model that we're considering? The open user model that we are considering is that the fact that we allow the user to check his questions he has browsed, the questions that he has favorited, the tags and topics that of the questions favorited. So we do implicit data collection of the user and use that also to improve his questions. So for example, here if I go to a suggested question, I can just go to how to implement a hash map and go to that particular question and look at the suggested question on the right hand side. Or I could go to related questions which are a lesser score than the suggested question, but it could be a question that the user would want to browse. The related questions tag is based on the tag cluster that we built for the user. So we essentially are trying to leverage whatever we're using in the suggestions basis and give everything that the user might want to use. So the explicit data collection, like I explained, you can come to the profile page and add what he wants. Also, we have a stats page where the user can go see his tags in relation to his favorites and history and what he has liked and what he has not liked. This gives a really good open user model where the user knows where he is, what he is, and what data is being collected for him, and how his suggestions improve based on his data, because we are considering his history, we are considering his favorited questions. So what is a recommendation algorithm? I've talked so much about tag clusters, I've talked so much about favorite questions history. So how do we do it? So it's a pretty straightforward concept where we consider the acceptance rate of the previous set of questions, the vote count. So let's say I take 5 questions, I take each question separately, take their acceptance rate, vote count, what is their tag cluster score in regards to the current question. So let's say I'm in I'm going to suggestions again. I'm going to storing an array and hash map its value. So I take Java arrays array list as the current tag cluster I have. I determine what are the other tag clusters that I have liked. Now, if you look at favorites, these are the tag clusters I've liked. I try to determine if there's a stronger tag cluster correlation score between the question that I had that I want suggestions for and the questions that I've already liked or browsed. Based on that, we determine a score. We take the tag cluster score, the unique tag, the unique all found tag, and unique all found split tag, like I explained before. We pick the top 30% question with the related score, create the document for all these questions and the document for the current question, and we boost content for the current documents content, and but also we use previous documents content along with the tag clusters. So this gives us a really good set of suggestions based on your user history, the favorite tags, the current question, and current question related to previous questions. So this is our recommendation algorithm, and we're getting pretty good test results. The test results that we're getting is close to 75% to 61% accuracy in regards to next set of questions and what topics. The problem that we sometimes find is that the related tags sometimes cause a user to explore more, so that causes the accuracy to come down. So this is our project. You can check out our project at akhil project.heroku app, which has been hosted. You can create a login or sign up and look at how you implement the project. Thank you. Have a good day.